morning, friends. I am here again for my lecture on aircraft systems, and the topic of this lecture is power conversion and storage. My name is Dr. Dwivedhi, professor from Institute of Aeronautical Engineering, Hyderabad, India. These are the contents of the today's lecture. First, I will visit with the revision of this lecture, revision of my previous lectures, then aircraft electrical systems, electrical power uses, why 400 hertz of frequency, this we will be discussing, typical aircraft electrical system, engine driven AC generator, APU power, electrical power system components. So these topics I am going to cover. First, I will see about the revision. As you know, these aircraft systems, and we can divide these aircraft systems into 4 categories. That is the airframe system, then vehicle system, then avionics system, and the last is mission system. This electrical system which I am going to discuss here is a part of the vehicle system, and the electrical system is very important for the operation of aircraft equipments. Without electric, aircraft is not possible to fly. So, and how this electrical system is given for different components, how these things are working, these all things I have discussed in my previous classes. Today I am going to discuss again for aircraft electrical system, and if you see here, aircraft electrical systems. So the function of the aircraft electrical system is to generate, regulate and distribute electrical power throughout the aircraft. So the main function of this aircraft system, aircraft electrical system, is to generate the electrical power. So this is called the generation. Then it should be regulated. Regulate means as per the requirement, where we want how much voltage and how much ampere, accordingly it should be regulated, and it should be properly distributed to different parts of the aircrafts. Now, new generation aircraft rely heavily on electrical power because of the wide use of electronic flight instrument systems. So the modern aircraft generation rely heavily on the electrical power because we have different types of equipments, avionic equipments. They need different types of powers. Some need AC, some need DC. In AC also, they need a different frequency, different voltage, different other parameters. So, as per the modern generation or the new generation aircraft, they are heavily dependent upon the electrical power because of the wide use of electronic flight instrument system. Because we have different types of avionics system and they need a different type of power rating. So, our aircraft electrical system should be able to produce the power as per the requirement of the system. Now, electrical power uses. Where we have to use the electrical power. So, aircraft electrical power is used to operate aircraft flight instruments, essential system and passenger services. We can divide this uses of the power into 3 groups. One is the aircraft flight instruments. You can see that pilot is sitting in the cockpit and he has number of instruments in front of him, like altimeter, speedometer, then engine parameters, then altimeter, then climb ROCI, rate of climb indicator, and some MFDs, and these all things, multiple flight displays are there, all has to be operated. So this all comes under the flight instrumentation. If you want to find out the altitude of the aircraft, we use navigation equipments, communication equipments, radar equipments. This all comes under instrumentation. Then we go for essential systems. So these are the systems which are operated by the aircraft electrical systems. And you see, nowadays we use for the flight control system. In flight control system, we use the radar, elevator, aileron, slats, slots, air brakes. All these systems are essential system, and also engine controls. The RPM of the engine has to be controlled, and these systems are used for different purposes. Then we should have the passenger services. In passenger services, the requirement of the passengers, those who are sitting on the aircraft, they all has to work accordingly. Passenger services, they are called the passenger services. If your passengers are sitting, they want light, they want air conditioning, they want other pressure regulations. These all things comes under the passenger services. So electrical power uses. So essential power is power that the aircraft need to be able to continue safe operation. So here we have seen the essential. So essential power. So what is the meaning of essential power? Essential power is power that is the aircraft needs to be able to continue safe operation. Okay, so like your flight control system, your engine control system, or your hydraulic system, pneumatic system, this all has to be operated for the safe condition of the landing, for the takeoff, for the cruise, for the loiter, for maneuvering. All type of systems we need, and there we need a power to operate the system. These equipments which are very much essential for operation and the safety of the aircraft, they are called the essential power requirement. Now, if I talk about the passenger services, power is the power that used for the cabin lighting. You might have seen in passenger aircraft, Airbus and Boeing, and in front of the passenger you have the light. This you can switch on. So this you can see. You can make the air conditioning, operation of entertainment systems. Your a small TV is in front of you that you can operate. Preparation of the food, you can heat your food. These all things are used for the passenger purposes. So these are the not very essential, but it is also for the comfort of the passenger. We should also make sure that these services are also working with the proper electrical power. So aircraft electrical component operates on many different voltages, both alternating current and the direct current. However, most of the system uses 115 volt AC at 400 hertz. So in aircraft we use this much volt and this much hertz. If you see our aircraft, our household, we have 220 volt, 50 hertz. If you take the 300, 440 volt and 50 hertz, your industrial use are three-phase power, we use this, and for the household requirement, we use the 440 volt and 50 hertz for industrial purposes. Why we use here only we use the 50 hertz, but in aircraft we use 400 hertz. That I am going to discuss in a very much detail, and also little I have covered in my previous lecture also. So here in this class I am going to discuss in detail about this. Next is the 28 volt DC. So we use this. However, in some modern aircraft nowadays we use 270 volt DC. This is also for a very few aircraft, especially American fighter aircrafts like Raptor, F-35. These two aircrafts are using voltage 270 volt. This I will be discussing in detail. A separate class I will be taking for 270 volt. Why we use 270 volt this thing? This I am going to explain in my next class. Next we have 26 volt AC is also used in some aircraft for lighting purpose. So for the lighting of your cabin, your fuselage, your doors, your cockpit lighting, there we use 26 volt AC. So now questions come, in household or industrial purpose, we use 50 to 60 hertz, but in aircraft we use 600 hertz. What is the reason and why we use 400 hertz of the frequency for this type of aircraft operation for alternating current? So this is very, very essential that we have to understand that what is the need of 400 hertz. So if you see what is the meaning of the hertz, okay, so per unit time, how per cycle per second, how many cycles per second. So this is the 1 cycle and this is the 1 second. So it is called 1 hertz. So in this 1 second, how many times? So it is a 60 means 60 time it will like this. And if it is a 400 in the 1 second, this will go 400. Okay, 400 like this, like this, like this. So it will be like a very, very smooth. This, if it is a 50, it is like this. And if you have the 400, this will become like this, 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 like this. So it is a very smooth. It is like AC only. So we try to make, and most of the aircrafts are using 400 hertz frequency. Higher than usual frequency, such as 400 hertz, offer several advantages over 60 hertz, notably in allowing a smaller, lighter power supply to be used for military hardware, commercial aircraft operation, and computer application. Okay, so what is the first advantage of why we use? It is allowing a smaller component. The component will be small, lighter power supply. The wiring and other things will be very light in weight to be used, and this can be used for military hardware, commercial aircraft operations, and the computer application. So we use 400 hertz. It gives very less fluctuation. So a very small amount of wire can be used for this operation. As aircraft space is at a premium and weight is critical to aircraft engine thrust and fuel burn. As aircraft space is at a premium and weight is critical to aircraft engine thrust and fuel burn, and thus the aircraft range and engine horsepower per pound. So what happened? As the aircraft space is at a premium and weight is a crucial to aircraft engine thrust and fuel burn, and thus the aircraft range and engine horsepower per pound, 115 volt at 400 hertz offer a distinct advantage and is much better than the usually 60 hertz used in utility power generation. So what is the meaning? You know that allowing a smaller, lighter supply. So if you use a smaller component or a smaller generator or smaller wires and all, the weight of the aircraft will be reduced. If the weight of the aircraft is reduced, the thrust required by the engine is also reduced. So if the thrust is reduced, fuel burn, the amount of fuel consumption will also reduce. So in this way, the aircraft range and the endurance of the engine per unit pound of the weight is increased tremendously. That is why we use 115 volts at 400 hertz, and this offers a distinct advantage and is much better than the usual 60 hertz used on utility power generation. So normally we use 400 hertz because it gives reduction in weight, a tremendous amount of reduction in weight of the aircraft due to the every electrical component, their size and weight is reduced. This reduction in size and weight will give lot of benefit, and the aircraft will need less thrust. Fuel consumption will be reduced. In this way, the range of the aircraft will increase, the endurance of the aircraft will increase, and aircraft need less size of the wing. So this is very useful to use a 400 hertz of frequency. Next, I am continuing with the advantage of 400 hertz, why we use the 400 hertz. However, higher frequencies are also more sensitive to voltage drop problem. So that is also one issue. if you are using the 400 hertz and your voltage is dropped, then there is a problem, because it is more sensitive and there is a likely to damage your system. So reactive drops, on the other hand, are caused by the inductive properties of the conductor. Reactive drops are a function of both cable length and the AC frequency flowing through the conductor. With high frequency such as 400 Hz, reactive drops are up to 7 times greater at 60 Hz. So that is the very disadvantage. So if your voltage is dropping, so the reactive drops in 400 Hz which are used in aircraft will be 7 times higher than the 60 Hz which we use in our household services. So that is also a drawback. Now I am going to talk about power sources. What type of power sources and how many are there and why it is required. This I am going to discuss. From where we are getting the power. Sources means the source of power. How we get power in an aircraft. There are severe different power sources. Several different power sources on large aircraft to be able to handle excessive loads for redundancy and for emergency situation. Okay, so there are a number of different power sources on the large aircraft like your passenger aircraft, Boeing and Airbus 320 and all, to be able to handle excessive load. So they can handle the excessive load for redundancy and for emergency situations. So redundancy means failure resistance. So, and this is also can be used for emergency situations. These power sources include, so what are these? Engine driven alternating current generator. So first one is engine driven alternating current generators, auxiliary power units, external power, and ram air turbine. These are the 4 power sources by which we get the power on the aircraft. Now, typical aircraft electrical systems, what are these systems? Primary, that is a main power source. Next is the emergency power source. Then secondary power conversion equipments, system control and protection devices, interconnection network, power distribution system. So these are the typical power electrical system which are used on the aircraft. This I will be discussing in due course of time. So here we can see image of aircraft electrical power sources. So what are the power sources and where these things are located? Okay, so this you can see here. This is the wing of the aircraft. This is the fuselage. This body is called the fuselage. These are the wings. They are the tail, and here is the vertical stabilizer. Okay, here these are the engine. This is the left engine and this is the right engine. I am writing left or the right, and this you can see where these systems are located and how these systems are working. So here is the emergency circuit breaker panel. Inside this cockpit, on top of this cockpit here in this area, there are a number of circuit breakers and every system will pass through this circuit breaker. Pilot will on or off. He will press, or he or she will press the circuit breaker and system will be operation. So emergency CB panel is there. Then we have the cockpit control panel. Here cockpit control panel is there. Then forward battery is there. One battery is situated on the near the cockpit. Then we have here air driven gas generator. Air driven gas generator. It is also called the ram air turbine. Okay. Then we have the forward standby AC/DC power distribution assembly. This is what? It is a forward standby AC/DC power distribution assembly. Here if you see current transmitter assembly. This is the current transmitter assembly, this one, small one. Then if you see here in the left engine, this integrated driven generator, IDG. It is IDG1. Here in this also it is IDG1 and this is the IDG2. So next it is situated in the fuselage, the rear side. This is the secondary power distribution assembly. This is called the 4 number, secondary power distribution. And here we have the forward power and this is the secondary power. Then we have the aft standby DC power distribution. So forward, then secondary and then aft. Here if you see, here we have the auxiliary power unit APU, and APU is fitted on the vertical tail. If you see here, this is the aircraft. I am making the aircraft. You see here, this is the, here is the horizontal tail and this is the vertical tail. This is the wing and here, this is the vertical tail. Your APU, auxiliary power unit, is APU. This is installed here on this and exhaust is going here, inlet is coming from this direction. So this APU, this you can see very small and this is fixed on the vertical stabilizer. And then it comes to the left, right and auxiliary AC-DC power distribution assembly 3. Here we can see the external power receptacle. This is external power, means we want to give power supply for maintenance for the starting of the engine during the ground. We put the power here. So in this way, I have shown and depicted all the components of this electrical components or of the system of aircraft, with electrical system of the aircraft. All the major components are shown here. Now I will discuss one by one all the required component, that is the engine driven AC generator. Each of the engine on an aircraft drives an AC generator. Just now I told you, every engine here, just you can see this AC generator, this is the generator. A generator is fixed on the engine and by the speed of the engine, this is also rotated. So engine, there is some gearbox. Those gearbox are rotating the AC generator. Okay, so here is this engine driven AC generator. Each of the engine on an aircraft drives an AC generator. The power produced by these generators is used in normal flight to supply the entire aircraft with power. The power produced by these generators is used in normal flight to supply the entire aircraft with power. Now, auxiliary power unit, APU power. So, how this auxiliary power unit is supplied? Most often, the auxiliary power unit power is used while the aircraft is on the ground during maintenance or for engine starting. So, APU is a small engine which is fixed normally on the vertical tail. This engine, that is auxiliary power unit, is used for on the ground, especially for the ground maintenance or during the engine starting. First we start the auxiliary power unit and this auxiliary power unit will give power to the engine, main engine, then main engine will be started. Also during ground, if you want to do some maintenance or some servicing or for some testing of the aircraft systems, that time also we start the auxiliary power unit. Because it is a very small, the fuel consumption is very low comparing to the gas turbine engine which is used for the main engine. However, most aircraft can use the APU while in flight as backup power source. So it is also can be used as an emergency power supply during flight. If your main generator is failed, then APU can be started and power can be supplied for different power connection. One exemption to this is the Boeing 727, which only allows APU operation in the ground. Except Boeing 727, other aircrafts, APU can be used on the ground. So APU in this, which only allows APU in the ground. It is not used for the emergency operation during the flying in Boeing 727. Other than that, auxiliary power unit is used for emergency power supply during flight as well as during ground maintenance of the aircraft on the ground. Once we want to do some testing, some landing gear check, your hydraulic operation, pneumatic operation, or electrical power generation, or you want some navigation, communication, you want to test on the ground, every maintenance work has to be performed by the external power supply or by the auxiliary power unit. The main engines are not started for the maintenance purpose of the aircraft. That we have to ensure that we should not start, because the fuel consumption is very high. The life of the main engine is reduced. Engines are very costly. So in ground, we use only auxiliary power unit, and those power unit will supply power for the maintenance of the aircraft. This you can see here. I have shown you here. This is the vertical tail, and here exhaust is visible. This is the exhaust of the auxiliary power unit. This you can see here. This will go exhaust gases like this. So it is fitted on the aircraft. Now this is on the ground. So the same small engine, very small engine, it is fixed and it is kept on the stand ready to fix in the aircraft. So like this engine is inserted inside this. Inside this engine is removed from here and it is inserted here. So like this here, this you can see, here is the exhaust. This exhaust is visible here. So like this, APU are used on aircraft, and it is shown here for your clarity that how much it is. So it is not a very big engine, very small engine, some maybe 150 kg of weight. And the main engine, if you see, it will go to 500 or 600 or 800 kg of weight. But APUs are very small comparing to the main engine. So we will not start the main engine. We will try to use the APU for this type of activities. Now I will talk about the functions of APU. I have given some glimpse of this thing. Now I will go each functions, how the APUs are working. The primary purpose of an aircraft auxiliary power unit or APU is to provide power to start the main engine. So first it is giving power to the main engine. So first we have to start APU, and then APU will rotate the main engine. Turbine engines have large, heavy rotors that must be accelerated to a high rotational speed in order to provide sufficient air compression and self-sustained operation. So we need a very high power to rotate the main engine. That can be rotated by the help of auxiliary power unit. This process takes significantly longer and requires much more energy than starting a reciprocating engine. This process takes significantly longer and requires much more energy than starting a reciprocating engine. Okay, so longer and requires much more energy. So we need much more energy. A normal small generators or some rotor cannot be used. So we use a small engine that is called APU. Now smaller turbine engines are usually started by an electric motor. Normally if it is a small engine, this can be started by electrical motor. But big engine is not possible to start by the electrical motor. While larger turbine engines are usually started by an air turbine motor. Whether the starter is electrically or pneumatically powered, however, the amount of energy required is far greater than what could be provided by a storage devices, battery or air tank of reasonable size and weight. So for a bigger aircraft where big engines are used, your electrically rotating devices are not sufficient. So we need some devices that is called the auxiliary power unit. This auxiliary power unit itself is a turbo engines, but a small size. This turbo engine is connected to the main engine, and it will be, once this APU is started and started rotating, it will give rotation to the engine. And when the main engine is getting a sufficient RPM, the compressor will produce a sufficient pressure to burn the fuel. That time only fuel is injected and the main engine is started. So once the one engine is started, the second engine has to start it by the APU. In this way, APUs are very important, and this is not possible by small devices. And APU solves this problem by powering up the aircraft in two stages. First, the APU is started by an electric motor with power supplies by a battery or external power source or ground power unit. After the APU accelerates to full speed, it can provide a much larger amount of power to start the aircraft main engine, either by turning an electrical generator or by providing a compressed air to the air turbine of the starter motor. So how it is working? Just I am showing you here. First we will take a ground supply. This is the ground power. This ground power is given to APU. APU will start. As and when the APU has started, either this will give to the electrical generator, and that electrical generator will rotate the main engine. This is a big engine. I am writing this is the main engine. This main engine, APU will rotate. The rotation may be by electrically or by the compressed air. And we need a sufficient amount of RPM. RPM may be 20,000 RPM. Then only the pressure will be sufficient from the compressor. Then only it will start. Otherwise, it will not start. This ground supply is not sufficient to rotate that much speed. So this engine cannot be started with a small power supply. So we need a auxiliary power unit, which can be either by electrically generator or by providing a compressed air. Electrical generator or compressed air. Okay, so in this way it is operated. APU also has several auxiliary functions. It has got some other work. Also, not only the starting, electrical and pneumatic powers are used to run the heating, cooling and ventilation system prior to starting the main engine. So before starting the main engine, this APU is giving air conditioning, your heating, your ventilation, your small fans, all will start functioning by the help of APU. This allows the cabin to be comfortable while the passengers are boarding without the expense of noise and danger of running one of the aircraft main engine. Okay, so electrical power is also used to power up system for pre-flight checks. Some APUs are also connected to a hydraulic pump, allowing maintenance and flight crew to operate the flight control and power equipment without running the main engine. This same function is also used as a backup in flight in case of an engine failure or hydraulic pump failure. So in this way we can use, and this will work accordingly. So this is not only to start the engine, it can give the heating, it can give the cooling, it can give the ventilation. Okay, it can also electrically power for the maintenance, for the pre-flight check, for the crew operation and flight control and other equipment without running the main engine. If you start the main engine, it will consume lot of fuel, lot of pollution, lot of this, your fuel will be exhausted, your range and endurance of the aircraft will be reduced. Now, I am going to discuss about electrical power system and its components. What are the components which are associated with the electrical power system? So in this we have the AC generator, that is called alternating current generator. Constant speed drive, it is also called CSD, constant speed drive. Integral drive generator, it is called IDG. Transfer rectifier unit, it is called TRU, transformer rectifier unit. And then generator control unit, it is called GCU. So these are the few very important components of electrical power system. So I am going to discuss one by one, and please pay attention on that. First I will discuss about constant speed drive. Okay, so by name itself, the speed should be constant. So how we are going to achieve? Because the engine RPM will fluctuate as per the load of the aircraft, as per the maneuvering condition, or as per the wind condition of the aircraft, rain and other atmospheric turbulence. If you observe, your aircraft will not be able, your engine will not be able to give a constant speed. But how we get the constant speed? So the purpose of the constant speed drive, that is a CSD, is to take a rotational power from the engine, and no matter the engine speed, turn the generator at a constant speed. So what is this? If this is the engine, there is a shaft. This shaft is rotating, but this shaft may not rotate always constant. So we have to put a device, it is called the CSD. Oops, sorry. CSD. Okay, so this CSD, what it makes? The purpose of the constant speed drive CSD is to take rotational power. So it is taking rotational power from the engine, and no matter the engine speed, turn and generator at a constant speed. So this generator, if suppose here is the generator, it will give a constant speed. It is called G. It will rotate at a constant speed, given speed. Whatever speed of this, but your generator will rotate at a constant speed. So this is the CSD, how it is working. This is necessary because the generator output must be 400 Hertz. I told you that in aircraft we should have the 400 Hertz. So if your speed is not constant, you will not be able to generate 400 Hertz. CSD operation, the engine turns the CSD, which uses a differential assembly and hydraulic pump to turn the generator. So here what happened? Here we have the, in CSD we have the differential assembly. Differential assembly means it gives a different speed than the input. And there is a hydraulic pump. This hydraulic pump will pressurize and it will absorb the additional or the reduction of the speed, it will maintain. So your generator will get the sufficient amount of speed so that generator will maintain a constant speed. So engine turns the CSD, which uses a differential assembly and hydraulic pump to turn the generator. Next is IDG, integrated drive generator. Oh, what is this? It is also one of the main component of the your electrical system, power generation. Another method of regulating the generator speed is with the use of an integrated drive generator. It is called an integrated drive generator. And integrated drive generator is simply a CSD and generator combined into one unit. So in this what happened? In this one is the, here is CSD and here is the generator. Both are joined in a one unit, and in this it is called integrated drive generator. Okay, it is called IDG. It is a one piece. Here an IDG is simply a CSD and generator combined into one unit. Just I have shown here, it is a one unit like this. there are two ways to mount the IDG. So how we can mount the IDG? It can be coaxially or the side by side. Coaxially means it is a axis, so it can be like this, or you can make like this, side by side, like this. This is called side by side, and this is called coaxially. Okay, so this the mounting, and this is the axis. Here we have the two axes. Okay. So we have two types of mounting in this type of system. Now I will go for the next important component of this power generation. It is called the TRU, or transformer rectifier unit. So transformer rectifier units, TRUs, are utilized to 115 volt AC, 400 Hertz into 28 volt DC. So the purpose of this transformer rectifier TRU is to convert AC of this range or to DC of 28 volt DC. And why we do so? Because in aircraft, every component is not operated at 115 volt AC or 400 Hertz. There are few equipments like radio communication and all, they use 28 volt DC. So we need some equipment which can transform or convert from AC to DC as per the requirement. The machine or the system which is converting from AC to DC is called the transformer rectifier unit. Okay. So a transformer is used to reduce the voltage from 115 to 28 volt. At this point, the 28 volt is still AC current. So first transformer, it will convert from 115 to 28 volt AC. To change the current from AC to DC, a rectifier is required. So a rectifier is required. So first is the transformer. The purpose of the transformer is to reduce the voltage from 115 volt to 28 volt. And the next unit, after getting 28 volt, there is a rectifier. Rectifier will try to make this AC to DC. Each aircraft AC bus feed a TRU which feeds a DC bus. So every AC bus will be fed to the TRU. It will go to the TRU and TRU will convert into DC, and this will be fed to the DC bus bar. So I have just discussed about some main component, other generator control and monitoring device. Now I want to discuss about some other generator control and the monitoring. So what are the generator control units and how we can monitor and how we can control? A generator control unit, GCU, or voltage regulator, is used to control generator output. So we need a generator output as per our requirement. Generator circuit protection monitors electrical system parameters. So what are the parameters which the system has to monitor? So one is the voltage, another is the frequency, then overcurrent, undercurrent, and differential fault. So these are the systems which we have to operate. So this voltage, frequency, overcurrent, undercurrent, differential fault, this all things has to be done and has to be monitored. So load control sense real system load to provide a signal to the CSD for frequency control. Current transformers are used for current load sensing and differential fault protection. The electrical system control panel may be found either on the pilot's overhead panel or on the flight engineer's panel. So load control sends real system load to provide a signal to the constant speed drive for frequency control. So if load is more or less, the signal will be going to the CSD and it will maintain the proper frequency. Current transformers are used for current load sensing and differential fault protection. So if the load is increasing or the decreasing, current transformers are there, and this current transformer will be sensing and they will take necessary action to protect the fault. The electrical system control panel may be found either on the pilot's overhead panel or on the flight engineer's panel. So electrical system control panels may be on the top of overhead. This you can see. Pilot has to do like this, and there is a control panel. From there, pilot will be able to control. And or if it is old type of aircraft, there may be a flight engineers. In the flight engineers, he got a panel. In that, the flight engineer can take the action and it will take necessary precautions and it will try to rectify the fault. Function of system components. The basic function of the electrical system components are to generate power. So what are the main function of any electrical component? To generate the electrical power. That is the first and primary. Control electrical power. Then after that, you are generated. But how much you are generating? How much required for the system? Your generation should be as per the required and it should be in a controlled manner. Protect the electrical system. You should be able to protect the electrical system. Distribute electrical power throughout the aircraft. Distribute electrical power throughout the aircraft. It should be able to distribute. Now, as an engineer, we should know the following information. We should know the following information. We all are the engineer and we are working on the aircraft. We should be competent enough to understand what are the information required for this system. Electrical system operations, which describes primary and the secondary power sources, bus configuration with circuit breakers and connected loads for each bus. A copy of the bus wiring diagram or electrical schematic should also be considered for inclusion in the report. So, what engineers should know? Electrical system operation which describes the primary and the secondary power sources. So, we should have one operation in this primary and secondary operation sources. Bus, what type of bus configuration? With circuit breakers and connected. Load for each bus. A copy of the bus wiring diagram for electrical schematic should also be considered for inclusion in the report. Alternators and other power sources description and related data including such items as battery discharge curves, transformer rectifier unit, inverter, APU, RAD, etc. So this power source and its data and their discharge curves, like battery, how much percentage it is discharging in how much time. These all things engineer should know. So these are the points which every engineer or any flight engineer or the aircraft maintenance engineer, especially the electrical engineer of the aircraft, has to ensure that he is aware about this type of requirement. So now this wiring and the power distribution. So criteria provided in section 12.2, sizing, shielding, protection, routing, etc. Wiring interconnection accounts for majority of aircraft mishaps due to electrical system failure. Best design practices and airworthiness standards for aircraft electrical wiring system provided via AFGS, ARINAC, SAE, wiring aerospace vehicle, SAE, ARP. These are your wiring some standards, military standards, and this we have to follow as an engineer. So in my next class, I am going to discuss about electrical source on aircraft. In that, primary sources, secondary sources, emergency sources, ground sources, condition of power sources, classification of electrical loads, typical aircraft electrical system. These I am going to discuss in my next class. These are the references which I am referring in my class. Also, I am referring some website also. So, Moir, I and Seabridge, Aircraft Systems, Mechanical, Electrical and Avionics. This is the published by Professional Engineering Publishing Limited. Design and Development of Aircraft System and Introduction, AIAA Education Series, AIAA 2004. I am referring these two books. Also, I am referring some internet resources. And if any questions from your side, please, you are welcome to ask me in this email. @gmail.com. This is my email. You are requested to ask any question if you feel so in this my mail. So I am ending my session here. Thank you very much. Please do join my next class. And as I told you, these topics I am going to discuss in my next class. Thank you very much for joining this class.
Like, share and subscribe. Hit the bell icon for more updates.